everyone. My name is Vivek Srivastav and I am from ABES Engineering College, Ghaziabad. Today, in this video of Database Management System subject, I will cover the topic Keys in Database Management System. So, the topics which I will cover are cardinality ratio, introduction to keys, extended ER diagram or enhanced ER diagram, specialization, generalization, and I will also cover aggregation. So, first thing, constraints on binary relationship type. Relationship type usually have certain constraints that limit the possible combination of entities that may participate in the corresponding relationship set. Because we must know how many entities are going to be participate in a particular relationship type. These constraints are determined from the real world situation that the relationship present. For example, a student can be a part of exactly one department, and then we would like to describe this constraint in the database design, because this is very important in the basic of database design. So what is cardinality ratio? The cardinality ratio expresses the number of entities to which another entity can be associated via a relationship set. For a binary relationship type R between entities type A and B, the mapping cardinality must be one of the following. There are four types of cardinality, and the relationship must be one of the following. Number one, one to one. Number two, one to many, many to one, and many to many. One to one means both sides there should be only one entity. One to many means on the left hand side there may be one entity, and on the other hand there may be many entities, n entities. Many to one means on the left hand side we have a lot of entities, n number of entities, but in the right side we have only one entity. And many to many relationship type, there may be n number of entities on both the sides. So cardinality ratio, I will explain one by one. First of all, one to one. An entity in A associated with at most one entity in B. And an entity in B associated with at most one entity in A. As you can see in the diagram, this is very clear. A student opts mini project. So a single student can opt a mini project. So there is a one-to-one relationship, and it is represented using the one-to-one cardinality. As you can see that A is the set of students, B is the set of mini projects, and R is the sets of opts. So one student can opt only one mini project. This is the one-to-one relationship. One to many. An entity in A associated with any number 0 or more of entities B, an entity in B, however, can be associated with at most one entity in A. This can be easily understood with the help of the example. A department has M faculties. So department is single, but it can consist n number of faculties or m number of faculties. So there is a one to many relationship, and it is shown by the diagram where set A represent department, set B represent faculty, and relationship type R1, R2, R3, R4, R5 represent the has relationship. So department has n number of faculties. Many to one. By name it is clear. An entity in A, entity set A is associated with at most one entity in entity set B. However, an entity in B can be associated with any number 0 or more of entities in A. So as you can see in the example, multiple students belong to one department. So this is just the reverse case of one to many. So many students can belong to a single department, and it is shown by the diagram. Now fourth one, many to many. An entity in A is associated with any number 0 or more. It is very important. Make sure you cannot skip this part. An entity in A is associated with any number 0 or more of entities in B, and an entity in B is associated with any number 0 or more of entities in A. So there is a many to many relationship. By the given example, you can see many faculties can teach many courses. So if we have a set of faculties and we have a set of course, then there will be relation teaches, and this relation will be called as many to many relationship, because many faculties can teach many subjects and faculties can teach m subjects. So now next thing, participation constraints and existence dependencies. The participation of an entity set E in a relationship set R is said to be total if every entity instance in E participates in the at least one relationship in R. You cannot skip any entity from the entity set. This is called full participation. If some entities in E participates in relation R, the participation of entity set E in relation R is said to be partial. Here, if some entities may not take part in the relationship, then this kind of participation is known as partial participation. Total participation is also called existence dependency. This is the another name of the total participation. Now, total and partial participation, as you can see in the diagram, in the given diagram, total participation is shown by the double lines. Like you can see with the entity faculty, you have two lines, which is shown as total participation, which indicates the total participation of entities set in the relationship set, and partial participation is shown by a single line, which indicate the partial participation of any entity set in a relationship type. This is the total and partial participation. Now, important concept of DBMS, introduction to keys. What are keys? Primary keys, foreign keys, extended ER diagram. I will cover all the things with the help of introducing keys. Now, key is an attribute or a set of attributes of an entity type that helps to uniquely identify an entity instance in an entity set, and also is used to establish relationship between the different entity types. So two important keys which I will discuss here. Number one, primary key, and composite primary key, and second is foreign key. These two keys are very essential in the field of DBMS. Primary key. A table columns with the following set of features can be designated as the primary key. A table can have one and only one primary key. The basic characteristics of a primary key is that it can never be a null. If you assign any key to a primary key, like here, employee ID is considered as the primary key because it is underlined. So its value cannot be null. Its value is always unique. For each instance, every employee will have unique employee ID. The value once provided cannot be changed. Suppose you have a Aadhaar number, then Aadhaar number cannot be changed, but the details may be updated. But Aadhaar number is like a primary key, so you cannot change its character. Okay. The value once provided cannot be changed or become null during lifetime of entity. So it will remain constant. It will remain same during the lifetime of the entity. The given diagram, employee ID is the primary key. Composite primary key. In case a table does not have a single table column that can identify table rows uniquely. Suppose I don't have any single column which can uniquely identify the any tuple. Then we can combine two or more table columns to make the key. This combination of two or more table columns that can be used to identify table rows uniquely is called the composite primary key. Here, composite primary key example is company ID as well as employee ID, because employee ID, suppose 123 is belongs to company A, and employee ID 123 belongs to company B also. So 123, if we merge both the company's data, then employee ID 123 will be repeated. So in that case, A 123 and B 123 will work as a primary key for both the employees. Foreign key. A primary key of a table is called a foreign key to some other table. Then when that column is used to relate the two tables. Suppose here student have student belongs to department is the given ER diagram. So students roll number will act like the primary key, foreign key in the department's table, and department ID will act like the foreign key in the student's relation. Converting the above diagram into tables and connecting them with the primary key and foreign key. Suppose reference table we have department, department ID, department name, department location, where department ID is the primary key, and it is referencing in the table of student where roll number, first name, middle name, last name, DOB is the part of student's table, but department ID will act like the foreign key and its value is given in the department's table. So this is the concept of foreign key. Tabular view to correct primary key and foreign key. We have the table on the left hand side of the department and in right hand side the student. Department have three attributes: department ID, which is also called primary key. It is mentioned here as PK. Department name, department location. Three attributes is given in the department table, and student table have following attribute, which is given here. First name, middle name, last name, DOB, and department ID is the foreign key, which is the part of the primary key in the department table. But in the student table, we have roll number, which can act as the foreign key in the department table. So extended, now next topic is extended ER diagram or enhanced ER diagram. Is needed to design accurate database schemas that reflect data properties and constraint more precisely. Applications of extended ER diagrams are CAD, CAM, telecommunications. In this area, this particular enhanced ER diagram is very useful. This leads to the development of additional semantic data modeling concept, which is incorporated in conceptual data models termed as EER, that is extended ER. It includes the following concept. Number one, spatialization, generalization, attribute inheritance, and constraints on spatialization and generalization. Now, let's take an example and understand spatialization and generalization. If you see the diagram, then we have an arrow. The upward arrow shows the generalization and downward arrow shows the spatialization. Suppose you consider employee. Employee is a faculty or staff. It is the spatialization of employee. And staff and faculty is a employee is the generalization of the employee. So this is the overall structure by which we can understand the concept of generalization and spatialization. If we move downwards, then we can say that employee is basically a faculty. So overall, employee is a faculty or staff. It is considered as specialization of employee. But faculty or staff is a employee. It is the general category of general characteristics of the faculty or staff. This is the generalization and specialization. Now, aggregation. Aggregation is an abstraction through which relationships with its corresponding entities are aggregated into higher level entities. Department and section here used, and student will be seated in which department and which section. This will be aggregated with the help of this aggregation property of DBMS. So that's all from for this particular video, and these are some important questions which are very useful in your exam. What is cardinality ratio in ER diagram? What are keys and why are they important in the database design? What is an extended ER diagram? How does ER enhance the basic ER model? What is the difference between specialization and generalization in ER models? If you further want to study then you can refer these two books, Course and Navate of DBMS, which are very useful. So thanks for watching this video, and in the next lecture, I will cover the further syllabus of DBMS. Thank you so much.